In today's lesson, we are going to talk about the modifier static. We'll talk about it in terms of variables and in terms of methods, and when we can and cannot use static variables and static methods. So first, let's talk about our static variables. Now, static variables are sometimes called class variables, and the reason why they are called class variables is because they belong to the entire class. So let's think about what we have done all year. So far this year, we have really focused on instance variables. And an instance variable is created every time we make an object. Every object gets its own set of instance variables. These are things that were unique to the object. Examples were, let's say we were talking about a bank account, we would have the name, we would have the balance. Those are all variables that are unique for each bank account that has been created. And in order for these variables to even make sense, we have to have an object to be built. So we have to use the new operator and call its constructor. And essentially what happens is every time we create a new object, all of these variables will be created. They belong to the object, and every object that is created gets its own set of those variables. Now that's what we've been focusing on for the majority of the year. Now, static variables, on the other hand, they don't just belong to one object. They belong to the entire class. And there is only one copy that is made, and it is shared among all objects of this class. So, because it is shared among all objects, it does not require an object to be instantiated in order for this variable to make sense. When we declare a variable to be static, we want to use the reserved word static, and it's also important to recognize that local variables cannot be static. So let's just take a look at an example here. So in these three variables that we have, they're all, that should be a lowercase p. They're all private because instance variables should be private. They are all static, which means that there is one that is shared among every instance of this class. And two of these are also final. Because they are final, that means that they are constants. Now you might be asking, well, are all constants supposed to be final? Well, it depends. In most cases, it makes sense for them to all be static. And the reason why would be, let's say we had, if you think back to the times when we've used constants, we had them for tax rates. And we found a bill, and every bill that we generated had the same tax rates. Well, if you think about it, when we declared them as instance variables, every single object had its own set of those constants. And since they're the same for everybody, we really don't need to create a set for everyone. If we had a lot of bills that were generated, that would be an unnecessary amount of variables that were created. If we made those variables static, then, or made those constants static, then every object that's generated would all use that same constant that was created. So even if you had 1,000 bills that were generated, you still only had one set of constants that were made. Now in this last scenario that we see down here, this is also a static variable, and in this case, this is not a constant. Because it is static, it means that all instances of the class can access it, and this is a great way to kind of communicate among objects. So communicate among objects. So if you think about it, each object typically kind of does its own thing, right? It knows everything about itself, but that's all that it does know, and that's the whole idea behind encapsulation. Well, with a static variable, we can allow multiple objects to all have access to the same shared information. Let's say, for example, we had a static variable for the number of students in a class, and each class can have a different number of students. For example, one class period might have 24 students, one class period might have 32 students, and even though each class period has a different number of students, if you were to ask any student in that specific class how many students are in the class, they would all have the same answer because it would be a shared value among all of them. Everybody enrolled in second period Java has a class of 24 students, etc. So that's what a useful thing for a static variable is. Another way that a static variable can be useful is if you want to share information with future objects to be created. And we saw that in the book class. If you refer to this code segment that we see down here, this is similar to how we did the call number for our book class. We took a substring, so the first 3 letters of the author's last name, and then we added to that the next book num. And the next book num started at 100, and it was a static variable. And so the first book that we added to our library had a call number of last name 100. And then we increased by 1. So then the next book that was added was last name 101, last name 102. And what this does is this guarantees that even if the author has written multiple books, so the first 3 letters of their last name are the same, they all have a unique number at the end. And this use of a static variable is very helpful when we are trying to accumulate a total, get statistics, or provide a new identity. And this would be a perfect example of providing a new identity. A couple things to note here, that the static variable is declared and initialized outside of the constructor. So that's what we see going on right here. And that's necessary because if it were initialized in the constructor, then every single object would keep on redeclaring its value, and that's not what we want. Also notice that its value can be changed as long as it's not created to be final. If the static variable were final, making it a constant, then it could not be changed. All right, so with regards to static methods, a static method is what we call a class method. And this is a method that performs an operation for the entire class, not an individual object. And a great way to think of this is sometimes there is a certain task that needs to be done for every single object, and the specific object is not necessary, or maybe object data is not necessary. That's when you can have a static method. And when we call this method, it is called through the class name. And a perfect example of this is our math class. The math class is filled with static methods. And that's because in order to perform a mathematical calculation, we don't need to first have to have a math object. We just have to know what operation we want to do. So in this example here, I'm calling the math.pow method, which will take the power. So this will do 2 to the second power. And I don't need an object. All I need to do is tell the computer where to find that code. And I can find that code in the math class. So this is called through the class name. Another example of a static method that we've seen is public static void main. And we've written this line of code so many times. And the reason why this method has to be static is because it allows the method to execute without building an object. If you think about it, our main method is in our driver program. And we don't first create an instance of the driver, we just run the driver. And that's because this method is in fact static. It does not need an object made first. Now, very important distinction here. Static methods can only call static methods and static variables. So let's think about this. A static method is a method that can operate without having an object. So because of that, it's possible that no objects have been created. And when it is not called through a specific object. So because of that, I cannot call other methods that require an object or use variables that require an object. So that is why static methods can only access other static methods and other static variables. You've probably gotten that error message before when you've made a helper method in your driver program that said, static method main cannot call non-static method, whatever. And that's essentially because of this rule right here. We have to preserve what it means to be static. So static does not require an object, and therefore it cannot interact directly with anything that does require an object. All right, so last but not least, a common example of when we use static methods would be for our header method, or for any helper methods in the main class. That is where you will typically see the static. So any helper method in the driver program that is called from your main method. So this method right here, header, its sole purpose is just to print out the header for the lab, and it's kind of bunching up all the code, getting it out of the way so that when you look at your main method, we don't have to see all of this. When we call this method, we simply just say header. So if header and main are in the same class, then we don't need to say class name first. We just put the method name. On the other hand, if I'm calling a method that is not in the same class, then I have to use the class name. And that's what we see going on here. So because this method is not in a class, then I must use the math.pow first. All right, that's it. Have a nice day.